Tell us what this topic is about. Ato!
It's about SCOM, mitigating enterprise risk through separation of concerns.
Yes!
All right, thanks for joining me today. We're going to talk about something that I've seen cause absolute chaos in enterprise environments. And I'm talking about places with top-tier talent, solid budgets, the whole 9 yards. We're talking about SCOM security debt, and specifically how ignoring separation of concerns creates vulnerabilities that can expose just about every intellectual asset your company owns. Now, before we dive in, let me set some context here. I recently posted some archived documentation about the SCOM security model from 2010. That was more historical. This session is about practical application. This is about what happens when we don't follow these principles, and more importantly, how to implement them correctly from the start. Here's what we're going to work through over the next 45 minutes. First, we'll establish what separation of concerns actually means, and why it's so critically important for SCOM specifically. Then we'll walk through the core principles: least privilege, isolated service accounts, environment segregation. And finally, we'll get into the implementation details, how to actually do this in SCOM, using user roles and run as accounts. And we'll touch on how this ties into management pack development. This is intermediate level content, so I'm assuming you work with SCOM on a daily basis. You know your way around the console, you've imported management packs, you understand the basic architecture. Good? All right, let's get into it. So, separation of concerns. This is not a new concept. It's been around in security architecture for decades. The Wikipedia article on this goes back to Edsger Dijkstra's work in the 1970s. But here's the thing. I have seen this principle broken with complete disregard for basic security practices in way too many enterprise SCOM deployments. At its core, separation of concerns in security means no single account should hold excessive permissions. We're talking about isolating service accounts to specific tasks, specific resources, specific environments. One account, one job. That's it. Now, why is this critically important for SCOM? Because discovery workflows, monitoring workflows, probe actions, write actions, all of these execute through the agent and can potentially have hooks into every host, every application, every endpoint, every service that runs your company. When I say potentially, in some cases, I've seen this be a stark reality. Administrator privileges across the board. Every service account running as domain admin or local admin everywhere. And here's the kicker. Nobody can rotate these accounts without causing an outage, because nobody knows what's actually using them anymore. Let me be clear about terminology here before we go further. For the purposes of this session, when I say service account, I'm talking about the same thing as a monitoring workflow context. These are interchangeable terms. The account that a workflow runs under, that's your service account for that workflow. So what happens when we ignore separation of concerns in SCOM? Let me paint you a picture from real deployments I've worked with. First scenario, service accounts that cannot be rotated without causing an outage. And I'm not talking about a planned maintenance window outage. I'm talking about we don't know what will break if we change this password outage. This happens because one service account is doing too many things, touching too many systems, and nobody documented what those things are. Second scenario, an attack surface that exposes intellectual property across the entire organization. Here's how this plays out. You've got monitoring workflows running with elevated privileges, maybe domain admin, maybe local admin, on hundreds or thousands of servers. If any one of those accounts gets compromised by a bad actor, they can quietly hijack a monitoring workflow, inject a write action, and do whatever they want across your entire infrastructure. I've seen this. I've been called in to remediate this, and I can tell you, it takes months to unwind. In one case, it took an entire year of meticulous documentation, searching, interviewing teams across the organization, and every single change scrutinized by a change advisory board that didn't trust anything we were doing because the previous state was so bad. It is far better to implement this correctly from the start than to have to fix it later. You will be happy when audit comes knocking, and you can confidently say your house is in order. All right, so why is SCOM particularly vulnerable here? Why are we talking about this specifically in the context of Operations Manager? It comes down to the architecture. The SCOM agent sits on your servers, your workstations, your network devices. And workflows execute on that agent under the context of specific accounts. Those workflows can run scripts, query databases, check file systems, invoke APIs, restart services. They can do just about anything you can script or program. Now, here's where it gets interesting. By default, most monitoring workflows run under the local system account on the agent. That's already pretty privileged. But when you need to do something that requires elevation, maybe querying a remote SQL instance, maybe checking a file share, maybe invoking a web service with authentication, that's when you bring in run as accounts. And this is where I've seen things go sideways. The easy path, the shortcut path, is to create one run as account with administrator privileges and just use it everywhere. One account to rule them all. And that account gets distributed to every agent in your environment because you configured it with more secure distribution and clicked all agents. That's a security nightmare waiting to happen. So here's where we are. We've established what separation of concerns means, isolating accounts to specific tasks and resources. We've talked about why this matters for SCOM specifically. The agent architecture gives workflows extensive reach across your infrastructure, and we've looked at the real-world consequences when this is ignored. In the next part, we're going to dig into the core principles that make this work. Principle of least privilege, giving accounts only the minimum permissions they need. Isolated service accounts, one account per application or service, not shared. And segregation of environments, separate accounts for dev, staging, and production. Let's get into it now. All right, so we've set the table. We talked about what separation of concerns actually means, why SCOM's architecture makes it particularly vulnerable when you ignore it, and what the real-world fallout looks like when things go wrong. Now we're going to get into the principles themselves and how they actually apply inside SCOM. There are three core principles we're working with here: least privilege, isolated service accounts, and segregation of environments. These aren't SCOM-specific concepts. They come straight out of security architecture and software engineering. But they map directly onto how SCOM is designed to operate. And once you see that alignment, a lot of things click into place. Least privilege first. The principle is straightforward. A service account should have only the minimum permissions it needs to do its specific job, nothing more. Sounds simple. And it is simple, in principle. Where it breaks down is in execution, because the path of least resistance in any rush deployment is to hand over more permissions than needed and move on. In SCOM environments, that shortcut compounds over time in ways that become very hard to unwind. Here's a concrete example. A monitoring workflow needs to query a SQL database. Maybe you're checking a custom application, checking table row counts, checking job statuses. That workflow needs database access. What it does not need is read-write access. It does not need sysadmin. It needs read-only access to that specific database. That's the assignment. Read-only. Done. Permissions get updated when a new need is documented, justified, and approved. You don't pre-provision for permissions that haven't been established yet. That's not least privilege. That's just hoping nobody notices. The discipline here is intentional. Every permission you grant is a door you're opening. And in a monitoring environment where agents are sitting on hundreds or thousands of systems, every extra door is an extra risk. Keep the doors to exactly what's needed and nothing else. Isolated service accounts. One account, one job. That's the rule.
You create a unique service account for each application or service you're monitoring, and that account does not get shared across multiple applications or services. The reason for this is what security folks call blast radius.
If a shared account gets compromised, everything that account touches is exposed. If an isolated account gets compromised, you've got a problem, but it's a contained problem. You know exactly what that account had access to, you can rotate it, and you can assess the damage with confidence because the scope is defined. Here's how this breaks down in real SCOM deployments, because I've seen this pattern more times than I can count. A new application gets dropped into the environment. Maybe it's a third-party product. Maybe it's an internal tool. Doesn't matter. The team responsible for it needs monitoring stood up fast because there's a go-live date on the calendar, and monitoring was the last thing anybody thought about. So somebody says, hey, just use that SCOM admin account. It has access to everything. It'll work. And it does work. Right away. No friction. The monitoring is green, everyone moves on, and nobody thinks about it again. That's how it starts. That's exactly how it starts. A new toy gets dropped in, everyone shortcuts security because there's schedule pressure, and the path of least resistance is an administrator-level account. And here's the thing about SCOM admin accounts. They're easy to find. Everyone has them. Everyone knows where they are. So that shortcut is always right there, always available, always tempting. Now the product is live, the monitoring is running, and SOC just got swept under the rug. And it usually stays there. Audit doesn't typically catch this kind of thing because auditors are generally looking at access control lists, not monitoring workflow contexts. So it sits, and it compounds. 6 months later, someone adds another application, takes the same shortcut, and now that one shared account is doing 12 jobs across 3 teams, and nobody has a complete picture of what would break if it disappeared. That's how you end up in the year-long remediation I described earlier. It doesn't happen all at once. It happens one shortcut at a time. The discipline of isolated service accounts is about protecting your future self. It takes one extra step up front, one extra service account request, one extra ticket to your identity team, one extra run as account in SCOM. That's the entire cost. What you get in return is a blast radius that's contained, an audit trail that's clean, and a rotation process that doesn't require a change advisory board meeting and 3 weeks of impact analysis. Now, before we go further, I want to make a point that I feel strongly about, and it applies to everything we're covering today. If you don't have a privileged access management solution, a PAM tool, a vault, something, SOC is going to be very difficult to effectively manage and operate at scale. I'm not talking about a specific product. I'm talking about the capability. You need somewhere to store credentials securely, rotate them on a schedule, and audit who accessed what and when. Without that, service account passwords live in spreadsheets or in people's heads, and that is not a security posture. That's a liability. If your organization doesn't have this today, that conversation needs to be on your roadmap in parallel with everything else we're discussing. CyberArk, Beyond Trust, HashiCorp Vault. There are options across a wide range of budget levels. It's that foundational. Go have that conversation. Third principle, segregation of environments. Use separate service accounts and separate credentials for your development, staging, and production environments. They do not share accounts. They do not share passwords. They are separate environments, and they need separate identities. The naming convention is straightforward. If you have a production service account called Service X, then you have Service X Prod, Service X Dev, and Service X Stage. Clean, consistent, auditable. Anyone looking at that account name knows exactly what environment it belongs to, what its scope is, and what the blast radius looks like if it gets compromised. Production environments hold real data, real configurations, and real consequences. If a development workflow has a bug, and development workflows have bugs, that's the whole point of development, You do not want that bug executing under a production credential. You want it contained to dev. You want the damage, if any, to stay in the sandbox where it belongs. I've seen this boundary crossed, and it almost always happens because someone needed to test something quickly and the prod account was right there. And it worked fine, until it didn't. Keep your environments segregated. Small discipline, very large payoff. So we've got the three principles: least privilege, minimum permissions for a specific job, isolated service accounts, one account, one job, contained blast radius, segregation of environments. Dev, staging, and production each have their own identities. Now the obvious question: how does this map to SCOM? Where in the product do you actually implement this? The good news is that SCOM is built for this. The architecture supports SOC natively. You just have to use it intentionally. There are two places in SCOM where security and SOC get implemented: user roles and run as accounts. Those are your two levers. That's where this all lands. Before I walk through those, I want to point you to a resource that I think is genuinely excellent. Kevin Holman. If you've been in the SCOM world for more than 5 minutes, you know the name. Put together a security account matrix that serves as a solid blueprint for the monitoring platform operating under SOC principles. It covers the baseline accounts, their roles, their permissions, the whole picture. It's the foundation. Just search Kevin Holman's SCOM Security Account Matrix and you'll find it. Worth your time. User roles. User roles in SCOM are well documented and straightforward to understand. There are several of them: administrator, advanced operator, operator, read-only operator, author, report operator. Each one has a defined permission set inside the monitoring platform. For the most part, the non-administrator roles are appropriately scoped out of the box. An operator can acknowledge alerts and run tasks. A read-only operator can see things but can't change anything. These roles do what they say. I'm not going to walk through every role in detail because the documentation covers that well. What I will say, and I want to be direct about this, is keep the administrator role tight, really tight. There should be a small handful of accounts in that group: the people who administer the platform, a break glass account for emergency access. That is the whole list. What I have seen in the real world is the administrator role filled with Active Directory security groups, and those Active Directory security groups have hundreds of users in them, nested groups inside nested groups, effectively granting nearly an entire organization full administrative privileges to nearly every asset, application, database, and service in the company, all running through SCOM. If any one of those credentials gets compromised, and in an organization of that size, statistically, credentials do get compromised. A bad actor has the keys to the monitoring platform. And through the monitoring platform, they have reach into every system that agent touches. They can hijack a workflow. They can inject a write action. They can operate quietly through a channel that most security tooling isn't watching closely. And here's the part of that story I haven't mentioned yet. After spending a year hardening that environment, documenting everything, interviewing every team, every change under the microscope of a skeptical change advisory board, the NOC analysts started storing administrative credentials in plain text on file servers. Because they needed to do their jobs, and after the hardening, they didn't know how anymore. Nobody had trained them on the new model. Nobody had handed them the right tools. That's the other half of this problem. Implementing SOC without training and without process is like installing a deadbolt and forgetting to give anyone a key. The security is there, but the workarounds that come out the other side are sometimes worse than the original problem. When you implement this, bring your teams along. Make sure the people who operate the environment every day understand the new model and have what they need to work within it. Run as accounts. This is where SOC gets operationalized in SCOM for monitoring workflows specifically. A run as account is a credential wrapper. You take a service account, wrap it in a run as account object inside SCOM, and associate that run as account with specific monitoring workflows inside a management pack. When those workflows execute, they run under the context of that service account, not local system, not a shared admin account, the specific, scoped account you defined for that purpose. Here's how the flow works in practice. You've identified what your monitoring workflow needs access to. You've defined the service account with the minimum permissions required. You create the run as account in SCOM and associate it with the specific workflows in the management pack that need that elevation. Done. The management pack piece matters here. The author of the management pack, whether that's a vendor or an in-house developer, should know exactly which workflows require elevation. That conversation happens during development, during unit testing, before the pack ever gets near production. It gets designed in, not bolted on after the fact. One thing I want to flag on run as account distribution, because this is where well-intentioned people make a costly mistake. When you configure a run as account in SCOM, you have two distribution options: less secure, which distributes the credentials to all agents automatically, and more secure, which lets you specify exactly which systems receive those credentials. More secure, always. You distribute the credentials only to the systems that the workflows actually need to access. Not all agents, not the whole environment, just the systems in scope. The less secure option feels like it might just be a warning label. It is not. If you distribute a privileged run as account credential to every agent in your environment, you've put that credential on every system you monitor. That's the opposite of containment. More secure, specify your targets. Now, one more thing on identifying permissions correctly before we move on, because this deserves attention. Your first stop when figuring out what a monitoring workflow actually needs is always the application documentation. Most enterprise applications, especially anything with a vendor-supported management pack, will have security documentation covering service account requirements, minimum permissions, required roles, specific database access. That documentation is your starting point. It tells you what the vendor tested and validated. If the documentation is thin, or if it just says requires administrator access, which happens more than you'd think, your default posture is read-only. Monitoring does not typically require write access. It requires the ability to observe state. Is this service running? Is this counter within threshold? Is this job completing? All of that is read. Start there. If there are write actions in the management pack, auto remediation workflows, restart actions, look at what those write actions actually do. What system state are they changing? What's the minimum permission required to make that specific change? You don't grant administrator because a write action exists. You grant the specific permission that write action requires. Nothing more. And if you're inheriting an environment where none of this was documented, a very common situation, crack the management pack open. The XML is readable. Workflow definitions will tell you what resources are being accessed, what scripts are executing, and in many cases, what credentials are expected. It takes time. It is not a black box. The information is there. That's the full implementation picture. User roles, keep administrator tight. The rest are scoped by design. Run as accounts, scoped credentials, specific workflows, targeted distribution, designed in from the start. SCOM is built to do this right. The capability is there. It's just a matter of using it intentionally before the shortcuts pile up and the blast radius becomes something you need to clean up with a new project that could have been avoided. One more practical note on the user roles side of this, because I want to make sure the picture is complete. The non-administrator roles in SCOM, advanced operator, operator, read-only operator, author, report operator, are scoped by design. They can't do the kind of damage an administrator account can do. An operator can acknowledge an alert, run a task, put something in maintenance mode. A read-only operator can see the console but can't change anything. These roles are not the problem. The author role deserves a mention because it's sometimes overlooked. An author can create and modify monitoring objects, overrides, groups, certain views. In most environments, that's a small group of people, your management pack developers, your senior engineers who are tuning the environment. It should not be a broad role. Not because authors can cause catastrophic damage, but because you want to know who is making changes to your monitoring configuration, and keeping that role tight makes that accountability clear. The scope of each role, the permissions it carries, the users who belong to it, that's something worth documenting as part of your overall SOC implementation. Not because it's complicated, but because having it written down means anyone who needs to understand the environment can understand it without having to dig through the console. Clean documentation is its own form of security. That's the complete picture on principles and implementation. The three principles map directly to the two SCOM mechanisms. Least privilege and isolated service accounts land in run-as account configuration. Segregation of environments lands in how you name, scope, and manage those accounts across your tiers. And the administrator role in user roles is where the most common real-world failure happens, and where the tightest discipline is required. Get these right from the start, and your environment is in a defensible posture. Your audit conversation is straightforward. Your rotation process is clean. And when something does go wrong, and something always eventually goes wrong, your blast radius is contained, and your path to resolution is clear. So everything we've covered so far has been at the platform level. How SOC applies to the monitoring platform itself, how you configure user roles, how you scope run-as accounts, how you distribute credentials only to the systems that need them. That's the foundation. But there's another layer to this that doesn't get talked about nearly enough, and that's how SOC applies to management pack development. Because the decisions you make when you're building or evaluating a management pack are exactly where security either gets designed in or gets ignored. And once a pack is in production, fixing that is a much harder conversation. Let's start with something practical. If you're working with an existing management pack and you want to understand what security context a workflow is running under, the answer is in the XML. Pop the pack open and search for run-as. That's your starting point. It will take you directly to the run-as profile entity definition in the pack. Now let me explain what you're looking at when you find it, because there are two distinct things here that are easy to conflate. You've got the run-as profile and you've got the run-as account, and they are not the same thing. The run-as profile is a container. It's defined in the management pack itself, by the author during development. Think of it as a placeholder. A named slot that says this workflow requires elevation, and here is where the elevated credential will be plugged in. The profile doesn't hold the credential, it just marks the spot. The run-as account is what you create in the SCOM console. That's where the actual credential lives. The service account, the username, the password, stored securely and associated with the profile. When the workflow executes, SCOM looks at the run-as profile, finds the run-as account associated with it, and runs the workflow under that account's context. That's the handoff. Profile is defined in the pack. Account is defined in the console. They meet at runtime. Take a look at the screenshot here. You can see the run-as reference in the XML, and you can see exactly how the profile is tagged to the workflow. This is what it looks like when a management pack author has done this correctly. Now here's something important to understand about what happens when they haven't. If a run-as account is not created in the console and associated with the profile, SCOM doesn't throw an error and stop. It falls back. It uses the default action account. On a Windows-based agent, The default action account is local system. On network devices and cross-platform systems, it's whatever account has been configured at that endpoint to handle monitoring. And the collective groups generally understands what that means in terms of permissions for their specific environment. Local system is already a highly privileged account on a Windows system. It has broad access to local resources. That workflow is running with the exact privileges it needs for Windows monitoring, but not for hosted programs, applications, or services. All these things can be vendor or in-house products. This is also why the identification step I talked about earlier matters so much. Before you ever touch the console, you need to know which workflows in a management pack require elevation. The XML tells you. Search for Run As, look at what's tagged, and you have your list. From there, you create the appropriate service accounts. You build the Run As accounts in the console. You associate them with the profiles, and the pack runs exactly the way it was designed to run, with scoped credentials. Now, one thing I want to be direct about. It is very common for vendor management packs to ship with no Run As profile defined at all. No elevation markers, no profile containers. The whole pack runs under the default action account. Again, that is not an issue because no workflows required elevation, and that's completely legit. But what it means operationally is that everything those workflows do, they're doing as local system, or as whatever default account your environment is running. You need to understand that when you're evaluating a vendor pack, because it affects your security posture whether or not the vendor documentation mentions it. If you crack that pack open and you don't see Run As anywhere, that's not necessarily a problem, but it is information. It means those workflows are running as default action account, and you need to decide if that's acceptable for your environment, given what those workflows are actually doing. All right, now let's talk about building a management pack with SOC as part of the design from day one, because this is where it gets straightforward in a way that I think surprises people. When you're gathering requirements to develop a new management pack, whatever it is you're monitoring, the security conversation is part of requirements, not an afterthought, not something you revisit after the pack is written. It happens when you're defining what the pack needs to do. The question you're asking at that stage is simple. Does this workflow need to access a resource that requires credentials beyond the default action account? If the answer is yes, a Run As profile gets defined for that workflow. That's the entire decision process. On the implementation side, it's a couple of lines of XML. You define the Run As profile entity in the pack. That's your container. You tag each workflow that requires elevation with an explicit reference to that profile. That reference is what SCOM reads at runtime to know that this workflow needs elevated context. The wiring between the profile and the actual credential happens in the console when you create the Run As account and associate it. The pack itself just needs to declare the need. The console satisfies it. This is what I mean when I say design it in. You're not writing complex security logic into the pack. You're making a declaration in the XML that says, this workflow needs a named credential context, and here is the profile that represents it. 2 lines, maybe 3. And from that point forward, SOC is enforced for that workflow automatically at runtime. Ask the question during requirements. Define the profile during development. It costs almost nothing at that stage. It costs a great deal to fix later. Now I want to touch on cross-platform environments, because if you're monitoring anything beyond Windows, and most enterprise environments are, the SOC conversation looks a little different, and it's worth spending a moment on it. On Linux and Unix systems, the SCOM agent handles elevation differently than it does on Windows. When a workflow needs to execute with elevated privileges on a cross-platform host, it doesn't use a credential stored in a Run As account the same way a Windows workflow does. What it does is run the command using sudo elevation. The sudoers file is a configuration file on Linux and Unix systems that defines which users or processes are allowed to run specific commands with elevated privileges and under what conditions. It's the Linux equivalent of granular permission delegation. When the SCOM agent needs to execute a privileged command on a Linux host, it references the sudoer's configuration to determine whether that command is permitted and under what context. This is why any administrator implementing SOC across a mixed environment needs at least a working understanding of sudoer's file configuration. You don't need to be a Linux administrator, but you need to understand the concept, because the principle is identical to everything we've been talking about for Windows. You define exactly what commands are permitted for exactly which accounts on exactly which systems. Minimum privilege, explicit scope, no blanket elevation. The same logic applies to network devices, to API-based monitoring, to HTTPS calls that require authentication or encryption, and to any other endpoint that isn't anonymous. Every one of those has its own mechanism for handling credentials and permissions. The SOC principle doesn't change based on the endpoint. What changes is the implementation detail, the specific configuration file, the specific authentication method, the specific credential store. But the question you're asking is always the same. What is the minimum permission this workflow needs to do its job on this specific endpoint? And how do I scope the credential to exactly that? That consistency, the same principle applied across every endpoint regardless of platform, is what a mature SOC implementation looks like. It's not a Windows configuration, it's not a Linux configuration. It's a monitoring architecture that treats security as a first-class concern across the entire environment, from the Windows servers in your data center, to the network devices at the edge, to the Linux hosts running your application workloads. And when you've done that work, when every workflow has a declared security context, every credential is scoped to exactly what it needs, every endpoint is handled consistently, what you have is an environment you can describe to your security team, your auditors, and your leadership with complete confidence. Here is what each monitoring credential accesses. Here is why. Here is the minimum permission required. Here is the audit trail. That's the payoff. Not just tighter security, a clear, defensible, documented posture that holds up under scrutiny, and that you can maintain and operate without it falling apart the moment someone leaves the team or a new application gets dropped in without warning. That's SOC-in Management Pack development. And that's how it connects everything we've talked about today, from the platform level all the way down to the individual workflow. And that's it for today. If any of this hit close to home, maybe you recognized your environment in some of what I described, just know that's actually a good thing. Awareness is step one. Thanks for watching. Stay sharp.